welcome to the third Hackfest, third TeraFlow Hackfest. My name is Lluis Gifre. I'm the chair of the technical steering committee of TeraFlow. For today's Hackfest, today and tomorrow Hackfest, the plan is that we will, the topic is playing with P4 forwarding capacities of TeraFlow. There is some active development in that specific functionality. It's mainly led by UBTech. In this case, we have Panayotis and Georgios here that took the time and the effort to prepare this Hackfest. So thank you very much for this huge effort. I will start just with a brief, let's say, introduction 101 on TeraFlow. Probably most of you already know what is TeraFlow, so I will not spend so many time. Before that, and as Sylvia said, you have here these USB sticks and disk. In case you don't have the virtual machine, you can copy directly from the disk. This probably will be quicker than if all of you or many of you start downloading them through the Wi-Fi. Some details here for the virtual machine. I mean, take into account that the username changed with respect to previous virtual machines. So if you are used to the previous virtual machines, now it's not TFS, it's TeraFlow, the username. Besides that, in previous Hackfest, we were using a virtual machine that was configured with a classical NAT network. In this case, it's classical NAT from VirtualBox. In this case, it's the NAT network. It's configured as in the wiki. You have the details here. I will not spend time here. And the IP address is configured to be dynamic, so you will get the DHCP address for that. I guess that's all. Probably Panayotis later will bring you additional details, so I don't want to spend more time on that. I will jump directly to the introduction. Well, here, this is classical question. Probably, I'm borrowing this question from Ricard. It's kind of a question that always people always ask Ricard, and he always says essentially the same. Alert of spoiler, yes, we need yet another SDN controller. The point is that, you know, I mean, we have many SDN controllers nowadays. Most of them are quite mature, quite complete. The problem is that if you check the number of contributions they are receiving in the last months, years, it's significantly low. That means at the end we have some needs, some new requirements for the new generation networks that are being developed and are planned for the future. That means 6G and beyond and so on. So if we have an SDN controller that has no active development, we are in trouble. With TeraFlow, we want to release and provide an SDN controller that can fulfill the requirements for the current and also the future networks, architectures and infrastructures. That's why, well, TeraFlow at the end, we can go through all the points, but probably you're most interested in the second part, so I will skip a bit all the details. The important points here is that we are trying to bridge what the industry needs with what we can provide with the standards for SDN. It's completely open source. We are following an Apache to a license. That means you can download the code, you can tweak it, you can contribute whatever. You just need to be a member of Etsy to be able to contribute to the community. It's container-based. That means the controller is broken into different parts, each of them with well-defined responsibilities that interact among them through network connections. And in particular, these microservices are deployed on top of Kubernetes. That means we inherit the benefits of a Kubernetes-based environment. Another additional point that is good to know is that forgot point. Well, anyway, yeah, let me jump. The community for TeraFlow it's growing. In this regard, we have in this slide we try to cover the different participants in the TeraFlow. The problem is that this slide it's always old, so it's always outdated. So we keep to try upgrading it, but if at some point you want to see which is the current list of participants, you always can visit the Etsy portal where you have all the official participants in the TeraFlow community. This is the architecture for the TeraFlow. As I was mentioning, it's based on microservices. These microservices are interconnected by means of a gRPC-based bus, each of them with different responsibilities. I will say the main focus for today's Hackfest will be essentially in the SBI, because there is where we have the P4 plugin that we will be using to interact with the different network devices. But besides that, we support many other SBIs. In particular, we support OpenConfig for P4-based, for packet-based routers and switches. We support the IETF data models, IETF topology, if I'm not wrong, to manage the microwave links. Well, P4, as you will see later, for switches. ONF, especially for the optical network. ONF Transport API, and well, essentially that's it. You have here all the details. I described it quickly, just to don't borrow time for the presentation. Also, white config, it's what I mentioned. For P4, I skip because UVTech will bring better details than myself here, so don't want to borrow time here. For the MBI, we are right now supporting a number of interfaces. Some of them are mature, like layer 2 VPN. Others, and layer 3. So others are under development. For IETF slice, for instance, we have some preliminary support, but we are still working on that. And the IETF, it's the IETF topology on the NBI. It's something that is planned in order to expose the topology. Besides that, the device inventory, it's work in progress. In this case, on Telefonica side, they are working hard on that, and we hope to release it in next version of TeraFlow. This will be release 3. For the ONF Transport API, it's still not support. It's just planned. Hopefully, it will land maybe not for release 3, but for release 4. And finally, the MEC bandwidth management API. We have a preliminary version of this API that is right now being tested, and it's planned to be merged soon. If you have questions, you need whatever, or maybe you are interested in getting in touch with TeraFlow, you can always point to this tfs.etsy.org webpage. This is our single point of entry. From there, you can reach the code repository that is hosted at Etsy. You can reach also the invite links for Slack and the emails for support, instructions for joining the community, get in touch with the different events and the plans and so on. Okay. By the way, this is outdated. Sorry, my bad. Forgot to update this part. And the point on the TeraFlow here in this scope of research projects and standards and so on is that with TeraFlow we want to bridge the gap between, among others, the research projects and the industry with the standards. So the project started as an 5GPPV project, and afterwards we created the Etsy community. Now as TeraFlowSDN, and this provides some additional value that enables many research projects right now in the SNS and outside SNS to use this this new SDN controller. Okay. The good point is that many projects from this slide are both, let's say, users of TeraFlow, but also contributors. So it's kind of we have the two sides of the coin with the project. Some demonstrations that we carried out. We started at this TeraFlow project with an initial demonstration where we were integrating the open source Mano with TeraFlow. It was a very preliminary version of TeraFlow. The point here was that from out of the box, we are supporting the integration between both Etsy projects. So you can configure TeraFlow as a one infrastructure manager for open source Mano. In that way, that you can deploy multi-site network services and configure the transport network between these network services through the TeraFlow. We also did some other demonstrations on cybersecurity, where in this case we were using unsupervised anomaly detection in order to detect some undesired conditions in the network and mitigate them. So we were using the cybersecurity framework for that. We had other demonstrations where we were playing with transport network slices with SLAs. In this case, it was a highly available connectivity service that was supported by a primary plus a backup service. We also demonstrated in other conference the use of multiple instances of TeraFlow in order to manage different domains in a way that each domain had no view on the details from neighbor domains. So for instance, when you have different domains managed by different network operators and they want to keep hidden the network details, in this case we were using blockchain to share abstractions of the topology and to forward the request on deployment for transport network slices. We did other additional demonstrations. Again, this one was using machine learning to detect the anomalies on the optical services. This was presented at OFC 23. And also we were doing some other experiments demonstrating how to automate the whole network, the deployment of services in a multi-technology, multi-layer network with, with many different types of devices in between. And well, I don't want to borrow more time. We could be speaking as an introduction for hours, but I think you are more interested in starting with P4 and the hands-on. So I pass the token to Juvitech, Panayotis, and Georgios. And well, I hope you will enjoy the Hackfest. And for sure, if at some point you have any question or you want to know something else, feel free to contact us.